This is a recast of the 7,500-word piece, Introduction to Machine Learning, ML, from Schneepat.com. This article is about machine learning, ML, and its applications in various fields such as healthcare, finance, and autonomous vehicles. It discusses the definition of ML, its importance, history, types of algorithms, and its impact on industries. The article also highlights the challenges and future prospects of ML. Let's listen in.
Today, we're diving into the world of machine learning, ML, a rapidly growing field that has the potential to revolutionize how we solve complex problems and make informed decisions. ML intersects with computer science, mathematics, and statistics, and it's been successfully applied in diverse domains such as healthcare, finance, and autonomous vehicles.
That's right. And to start off, let's define what machine learning is. It's a subset of artificial intelligence, AI, that focuses on developing algorithms and models that allow computers to learn from data inputs and make predictions or decisions based on that data. The aim is to enable computers to automatically learn and improve from experience without being explicitly programmed.
Absolutely. And machine learning is widely used in various fields such as computer vision, natural language processing, speech recognition, and recommendation systems. Its applications range from image and speech recognition to self-driving cars and personalized advertising. The ability for computers to analyze and interpret data, identify patterns, and make predictions or decisions is incredibly powerful.
That's why machine learning is so important in various fields. It has the ability to analyze and draw insights from vast amounts of data. In the medical field, ML algorithms can predict disease patterns and assist in diagnosis and treatment plans. In finance, ML models can identify fraudulent transactions and mitigate risks. In e-commerce, ML techniques can enhance personalized recommendations and improve customer satisfaction.
Exactly. And let's not forget about autonomous vehicles. ML plays a crucial role in their development by allowing them to learn from real-time data and make intelligent decisions on the road. The opportunities for innovation and advancement with machine learning are truly tremendous.
Yes, indeed. And it's worth mentioning that there are different categories of ML algorithms. They can be classified into three broad categories: supervised learning, unsupervised learning, and reinforcement learning. Each category serves a specific purpose and has its own set of algorithms and techniques.
That's right. And as ML continues to advance, its applications have expanded to various domains such as healthcare, finance, marketing, and more. The possibilities are endless.
Absolutely. Now let's take a step back and talk about the history of machine learning. It has its roots in the early 20th century with the development of computational algorithms and statistical models. The field of artificial intelligence emerged in 1956, encompassing the principles of machine learning. Researchers started developing algorithms that could analyze and extract meaningful patterns from large datasets.
However, progress was hindered due to limitations in computational power and lack of sufficient data. It wasn't until the late 1990s, with the advent of powerful computers and the abundance of data, that machine learning started to flourish. This marked the beginning of a new era where machine learning became an essential tool for various industries.
And it's worth mentioning some early developments in machine learning that laid the foundation for the advancements we see today. One notable landmark is the creation of the perceptron in the late 1950s by Frank Rosenblatt at Cornell University. The perceptron was the first artificial neural network capable of learning. It inspired researchers to explore the potential of neural networks and led to the development of more sophisticated algorithms.
Another important development is the introduction of decision trees in the early 1980s by Leo Breiman, Jerome Friedman, Richard Olshan, and Charles Stone. Decision trees provided a straightforward and interpretable approach to machine learning, allowing researchers to extract valuable insights from complex datasets. These early breakthroughs set the stage for the rapid progress and widespread adoption of machine learning in various domains.
Absolutely. And that brings us to the end of this section, where we discussed the definition and importance of machine learning, as well as its history and early developments. Stay tuned for the next section, where we'll dive deeper into the challenges and future prospects of this exciting field.
Welcome back, everyone. In the previous section, we discussed the evolution of machine learning algorithms and how they have become more complex and powerful over time. Now let's talk about the different types of machine learning techniques that are commonly used in practice.
That's right. One popular type is supervised learning, where the algorithm learns from a labeled dataset to make predictions or classify new instances. This type of learning involves creating a mapping function that takes input variables, also known as features, and predicts an output variable, also known as the target. The algorithm is trained by presenting it with a set of input-output pairs and adjusting its internal parameters to minimize the error between predicted and actual outputs.
Absolutely. Supervised learning is widely used in many applications, including image recognition, speech recognition, and natural language processing. For example, in image recognition, a supervised learning algorithm can be trained on a dataset of labeled images to recognize and classify different objects or scenes. This type of learning has been instrumental in advancing technologies like self-driving cars and virtual assistants.
Another type of machine learning is unsupervised learning. In unsupervised learning, the algorithms are trained using unlabeled data, meaning that the input data does not have any specified output value. The goal of unsupervised learning is to uncover underlying patterns or structures in the data. One common technique used in unsupervised learning is clustering, where similar data points are grouped together based on their characteristics.
That's right. Clustering can be used to find distinct groups within a dataset, which can be useful for market segmentation or customer profiling. Another technique used in unsupervised learning is dimensionality reduction, which aims to reduce the number of input variables while retaining the important information. This can be helpful in visualizing high-dimensional data or simplifying complex datasets.
Absolutely. Unsupervised learning has a wide range of applications, such as anomaly detection, recommendation systems, and data preprocessing for supervised learning tasks. For example, in anomaly detection, unsupervised learning algorithms can identify unusual patterns or outliers in data, which can be valuable for fraud detection or identifying manufacturing defects.
Exactly. Now let's talk about reinforcement learning. Reinforcement learning is another significant type of machine learning where an agent learns to interact with an environment by receiving rewards or punishments. The goal of reinforcement learning is to learn a policy that maximizes the cumulative reward over time. This type of learning is often used in robotics, game playing, and autonomous systems.
Absolutely, Ben. Now let's talk about the interpretability and explainability of ML models. As these models become more complex and powerful, it becomes increasingly challenging to interpret their outputs and understand the decision-making process behind them. Interpretability refers to the ability to explain or understand the behavior and results of ML models. Explainability, on the other hand, focuses on providing clear and concise explanations to users for the actions and decisions made by ML models. Achieving interpretability and explainability is crucial for building trust in ML models, ensuring ethical decision-making, understanding biases, and facilitating the adoption and acceptance of these models in various domains.
Absolutely, Paul. Now let's move on to the impact on employment and the workforce. Machine learning has the potential to automate repetitive and mundane tasks, which can free up workers to focus on more complex and creative endeavors. This can lead to increased productivity and efficiency in industries such as manufacturing and customer service. However, there is also a fear that machine learning algorithms will replace human workers entirely, leading to job displacement and economic inequality. The reality is likely to be a combination of these scenarios, with some jobs being eliminated while new ones are created, requiring a different set of skills. It's crucial for individuals and societies to anticipate and adapt to the changing landscape of employment in the age of machine learning.
That's right, Ben. And finally, let's touch upon the future of machine learning. The article highlights that the future looks promising as the field continues to evolve and expand. One potential area of growth is in the development of advanced algorithms that can handle more complex tasks and datasets. This could lead to significant advancements in areas such as natural language processing, computer vision, robotics, and autonomous systems. Additionally, the integration of machine learning with other emerging technologies like blockchain, quantum computing, and edge computing could further enhance its capabilities. Moreover, the ethical implications of machine learning are gaining attention, and there is increasing demand for transparency and fairness in algorithmic decision-making. As machine learning becomes more integrated into various industries, it is expected to revolutionize the way we live and work, making it an exciting field with vast possibilities for the future.
Absolutely, Paul. The future of machine learning is bright, but it's important to approach it with caution and consideration for these key points we've discussed today. One major advancement in machine learning is the integration of ML with big data analytics. This allows organizations to make data-driven decisions and gain valuable insights. Big data refers to the large and complex data sets that cannot be easily processed with traditional methods. By combining machine learning algorithms with big data analytics, organizations can uncover hidden patterns and trends that can lead to more efficient and effective decision-making.
That's right, Ben. Another significant trend in machine learning is the emergence of deep learning techniques. Deep learning refers to a subset of machine learning algorithms that are inspired by the structure and function of the human brain. These algorithms, called neural networks, consist of interconnected layers of artificial neurons that learn to recognize patterns and make predictions through a process called training. Deep learning has revolutionized the field by enabling the development of complex models capable of processing unstructured data, such as images and natural language.
Absolutely, Paul. Another important trend in machine learning is the growing interest in explainable AI. Explainable AI aims to provide transparency in the decision-making process of machine learning models. This is particularly important as machine learning models are being used in critical domains such as healthcare and finance. Explainable AI ensures that these models can be understood and trusted by humans, allowing for better accountability and ethical decision-making.
That's a great point, Ben. When it comes to machine learning algorithms, continuous learning and adaptation are crucial. Machine learning algorithms are designed to process large amounts of data and make predictions or decisions based on patterns and trends. However, as new data is constantly generated, these algorithms need to adapt to these changes to ensure accurate and reliable results. Continuous learning allows the algorithm to update its models and parameters based on new information, improving its performance over time.
Absolutely, Paul. Continuous learning also helps machine learning algorithms avoid biases and outdated assumptions, ensuring that they remain relevant and effective. This is particularly important as societal and technological changes occur, as the algorithms need to adapt to these changes to provide accurate predictions and decisions.
Machine learning has the potential for vast applications in various domains. In the healthcare industry, it can aid in the diagnosis of diseases by analyzing medical records and symptoms to predict possible conditions. Machine learning algorithms can also assist in drug discovery by identifying potential drug candidates. In the financial sector, machine learning can help with fraud detection by recognizing patterns and anomalies in transactions. Additionally, it can optimize transportation systems by analyzing data to enhance route planning, reducing congestion and fuel consumption. These potential applications demonstrate the wide-ranging impact machine learning can have across multiple industries.
That's right, Paul. Machine learning is a branch of artificial intelligence that focuses on creating algorithms and models that enable computers to learn and make predictions without being explicitly programmed. It has become increasingly popular due to its ability to automate and optimize complex tasks, such as image recognition, natural language processing, and recommendation systems. Machine learning has opened up new possibilities in various industries, including healthcare, finance, and e-commerce.
Absolutely, Ben. In conclusion, machine learning has emerged as a powerful tool in the field of artificial intelligence, with the ability to discover patterns and make predictions from data without being explicitly programmed. It has shown tremendous potential in various domains, including healthcare, finance, and marketing. However, there are still challenges that need to be addressed, such as the interpretability and transparency of machine learning models, as well as ethical considerations surrounding the use of sensitive data. Nonetheless, with continuous advancements and research in the field, machine learning holds great promise for revolutionizing industries and improving our everyday lives. That's right. Reinforcement learning algorithms can be trained to perform complex tasks by learning from trial and error. For example, in game playing, a reinforcement learning algorithm can learn to play chess or Go by playing against itself and adjusting its strategy based on the outcomes. This type of learning has led to significant breakthroughs in game playing AI and has even surpassed human performance in some games.
Lastly, there is semi-supervised learning, which combines elements of both supervised and unsupervised learning. In semi-supervised learning, a small amount of labeled data is used along with a large amount of unlabeled data. This approach leverages the benefits of both types of learning and can be useful when labeled data is scarce or expensive to obtain.
Absolutely. Semi-supervised learning has been successfully applied in various domains, such as text classification, where a small labeled dataset can be used along with a larger unlabeled dataset to improve the accuracy of the classification task.
That's right. Each type of machine learning has its unique strengths and weaknesses, making it suitable for different types of tasks and datasets. The choice of the appropriate type of learning depends on the specific problem at hand and the availability of labeled or unlabeled data.
Absolutely. And that brings us to the end of this section, where we discussed the different types of machine learning techniques, including supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. In the next section, we'll delve deeper into the challenges and future prospects of machine learning. Stay tuned.
Welcome back, everyone. In the previous sections, we discussed the evolution of machine learning algorithms and the different types of machine learning techniques. Now let's talk about the applications and impact of machine learning in various industries.
That's right. Machine learning has revolutionized industries like healthcare, finance, and transportation. With the exponential growth of data and advancements in computing power, machine learning algorithms can now process and analyze vast amounts of information to make meaningful predictions and decisions.
Absolutely. Machine learning has the potential to transform the way we approach problem solving and decision making. It allows us to extract valuable insights from data that were previously impossible to obtain. For example, in healthcare, machine learning algorithms can analyze patient data to predict disease outcomes and personalize treatments.
That's a great example. Machine learning can also automate tedious and repetitive tasks, freeing up human resources to focus on more complex and creative aspects of their work. For instance, in finance, machine learning algorithms can automate tasks like fraud detection or portfolio optimization.
Exactly. The successful implementation of machine learning requires a deep understanding of the underlying algorithms, data preprocessing techniques, and model evaluation methods. It's important to have a solid foundation in these areas to ensure accurate and reliable results.
Absolutely. And as the field of machine learning continues to expand, there is a continuous need for further research and development to enhance the performance and capabilities of these algorithms. Researchers are constantly working on improving existing algorithms and developing new ones to tackle increasingly complex problems.
That's right. And with the increasing availability of data and advancements in technology, the possibilities for machine learning are endless. It has the potential to revolutionize industries and improve decision-making across various domains.
Absolutely. Machine learning is an exciting field that continues to evolve and have a profound impact on our lives. Whether it's personalized recommendations on streaming platforms or fraud detection in financial transactions, machine learning is shaping the way we interact with technology.
That's correct. And one popular algorithm in machine learning is clustering. This technique groups similar data points together based on their characteristics or attributes. It helps identify patterns and relationships within a dataset. Clustering is used in various applications such as customer segmentation, image recognition, and anomaly detection.
Exactly. Clustering allows us to understand the similarities and differences within a dataset, which can be valuable for making informed decisions. Another widely used algorithm in machine learning is dimensionality reduction. As the name suggests, it aims to reduce the number of features or variables in a dataset without losing significant information.
Dimensionality reduction is particularly useful in reducing computational complexity and improving the efficiency of machine learning models. It includes methods like principal component analysis, PCA, T-distributed stochastic neighbor embedding, TSNE, and autoencoders.
Moving on, another fundamental approach to machine learning is reinforcement learning. In this framework, an agent learns to interact with an environment to maximize some notion of cumulative reward. The learner receives feedback from the environment in the form of rewards or punishments based on its actions.
The central idea of reinforcement learning is for the agent to learn from positive and negative experiences and make a sequence of decisions to achieve a long-term goal. It combines elements of supervised and unsupervised learning, as the agent is not explicitly told what actions to take, but rather learns to interpret reward signals to improve decision-making.
Reinforcement learning has been applied in various domains, such as robotics, game playing, and autonomous vehicles. It has shown promising results and continues to be an area of active research.
Absolutely. Now let's talk about some popular machine learning algorithms like Q-learning and deep reinforcement learning. Q-learning is a value-based algorithm that focuses on learning the optimal action selection policy for Markov decision processes, MDPs.
Q-learning uses an iterative process to update Q values, which represent the expected cumulative rewards for taking a specific action in a given state. This algorithm has been successful in solving complex problems and has been applied in areas like game playing and optimization.
Deep reinforcement learning combines deep learning with reinforcement learning, allowing the agent to learn directly from raw sensory input. This makes it suitable for complex tasks such as game playing, where the agent can learn from visual information.
Deep reinforcement learning has achieved notable success, demonstrating the potential of machine learning algorithms in solving real-world problems. It has been used in applications like autonomous driving, robotics, and natural language processing.
Machine learning is a rapidly growing field that relies on statistical techniques and mathematical models to analyze and interpret large amounts of data. It allows computers to learn and make predictions or decisions without being explicitly programmed.
The machine learning process involves several key steps, starting with data collection and preprocessing. This is followed by feature engineering, model training, evaluation, and deployment. It's an iterative process that requires continuous refinement and improvement based on new data and feedback.
And with the increasing availability of big data, powerful computational resources, and improved algorithms, machine learning is set to revolutionize industries and solve complex problems by providing intelligent and automated solutions.
That's right, Ben. And one of the most important steps in the machine learning process is data collection and preparation. The accuracy and quality of the collected data directly impact the performance of the models we develop. It's essential to collect a diverse and representative dataset to build effective machine learning models.
Absolutely, Paul. Data collection can involve various methods such as surveys, experiments, or web scraping. Once the data is collected, it needs to be prepared for analysis. This includes cleaning the data by removing any inconsistencies or errors, handling missing values, and transforming the data into a format suitable for analysis.
Right, Ben. High quality and diverse data are crucial in machine learning. High quality data refers to accurate, complete, and error-free data. Without high-quality data, our machine learning algorithms may make incorrect predictions or decisions, leading to unreliable outcomes. And diversity in the data ensures that our models are not limited in their understanding of different perspectives and experiences.
Exactly, Paul. Diverse data helps us create robust and unbiased predictions, so it's important to collect and utilize high-quality and diverse data to achieve accurate and unbiased results in machine learning applications.
Moving on to data cleaning and preprocessing techniques. Raw data often contain inconsistencies, noise, missing values, and outliers that can negatively impact the performance of our models. Data cleaning involves identifying and correcting these issues through methods like imputation, removal of duplicates, and handling missing values.
Right, Paul. And preprocessing techniques involve transforming the data into a suitable format for machine learning algorithms. This may involve scaling, normalization, feature engineering, and dimensionality reduction. By applying these techniques, we improve the quality and usability of the data, resulting in more accurate and efficient machine learning models.
Now let's talk about model training and evaluation. Once our dataset is prepared, the next step is to select an appropriate learning algorithm to train the model. There are various algorithms to choose from depending on the problem at hand. During the training phase, the algorithm learns from the labeled examples in the dataset to create the model.
That's right, Paul. But it's important to ensure that our model is not overfitting the training data and can generalize well to unseen data. So we evaluate the performance of the model using metrics like accuracy, precision, recall, and F1 score to assess its effectiveness in solving the problem.
Absolutely, Ben. And one of the key challenges in machine learning is selecting the appropriate algorithms for specific tasks. There are different types of algorithms, including supervised learning, unsupervised learning, and reinforcement learning. The choice of algorithm depends on various factors, such as the nature of the data, the complexity of the problem, and the desired outcome.
And another important technique in machine learning is cross-validation. It involves dividing the data into multiple subsets or folds and using them iteratively as training and testing sets. This helps us obtain a more robust evaluation of our model by averaging the performance metrics across all folds.
Right, Ben. And those performance evaluation metrics like accuracy, precision, recall, and F1 score provide insights into how well our model can correctly classify instances and its overall performance. These metrics are crucial in determining the effectiveness of our machine learning algorithm.
Finally, let's talk about the concern of bias in machine learning algorithms. ML models are trained using historical data that can reflect societal biases and discrimination. If our historical data includes biased decisions made by humans, such as gender or racial bias in hiring practices, our algorithm could learn and replicate these biases when making predictions.
And this can lead to systemic discrimination and inequality. To address this issue, we need to mitigate bias in ML algorithms and ensure fairness and equal opportunities. Approaches like data preprocessing, algorithmic fairness measures, and diversity in the development team can help promote ethical and unbiased machine learning systems.
Absolutely, Paul. It's crucial that we work towards mitigating bias to create fair and inclusive machine learning applications. One of the fields where machine learning is making a significant impact is healthcare. Machine learning algorithms have shown great potential in diagnosing diseases and predicting outcomes. For example, these algorithms can accurately detect early signs of diseases like cancer and Alzheimer's, improving the chances of successful treatment. They can also predict patient outcomes, helping healthcare practitioners make informed decisions about treatment plans and personalized care. Machine learning has also enabled the development of tools for analyzing large healthcare datasets, facilitating research and the discovery of new treatments. With its ability to uncover patterns and deliver precise predictions, machine learning has the potential to revolutionize healthcare and significantly improve patient outcomes.
That's absolutely right, Ben. The integration of machine learning into clinical practice does come with some considerations. It's important to ensure reliability, accuracy, and ethical considerations. This means rigorous evaluation and validation are necessary to address concerns related to privacy, security, and biases in training data. It's crucial that machine learning systems in healthcare adhere to these principles to maintain trust and ensure patient safety.
Moving on to another application of machine learning, let's talk about drug discovery and personalized medicine. Traditional methods of drug discovery have been time-consuming and costly, relying on trial and error approaches. But with the advent of machine learning, researchers can now analyze vast amounts of data to identify potential targets for drug development. Machine learning algorithms can examine multiple variables such as genomics, proteomics, and clinical data to predict drug efficacy and toxicity. This enables the development of personalized medicine, where treatment plans can be tailored to an individual's genetic makeup and specific disease characteristics. Machine learning has the potential to accelerate the drug discovery process and improve patient outcomes in the field of personalized medicine.
Absolutely, Ben. Machine learning is transforming drug discovery by enabling researchers to analyze complex data and make more informed decisions about potential treatments. By leveraging machine learning algorithms, researchers can identify promising drug targets more efficiently, reducing time and costs associated with traditional methods. Personalized medicine, in particular, has seen significant advancements with machine learning. By analyzing an individual's genetic makeup and disease characteristics, machine learning algorithms can help tailor treatment plans to maximize effectiveness and minimize side effects. This personalized approach has the potential to improve patient outcomes and revolutionize the field of medicine.
Now let's shift gears and talk about the applications of machine learning in finance. Finance is a rapidly evolving field that has seen significant advancements with the integration of machine learning techniques. By analyzing vast amounts of historical and real-time market data, machine learning algorithms can identify patterns and relationships that humans may not be able to detect. These insights can then be used to make informed investment decisions and optimize portfolio management. Machine learning has also been used in fraud detection, creditworthiness assessment, and automating financial processes, enhancing the efficiency of the financial industry.
That's right, Ben. Machine learning has made a profound impact on the financial industry by improving risk management, enhancing trading strategies, and predicting financial trends more accurately. By leveraging machine learning algorithms, financial institutions can analyze large datasets to identify patterns and make data-driven decisions. This can lead to more efficient risk management practices and better investment strategies. Machine learning has also been invaluable in fraud detection and prevention. Traditional rule-based systems often struggle to keep up with emerging fraudulent activities, but machine learning algorithms can analyze real-time data and identify anomalies that may indicate fraudulent behavior. This helps organizations proactively detect and prevent fraud, saving significant financial losses and maintaining trust in their systems.
Absolutely, Paul. Machine learning is transforming how the financial industry operates and revolutionizing the concept of financial decision-making.
And it's important to note that as machine learning becomes more prevalent in various fields, we need to ensure that biases are mitigated and ethical considerations are taken into account. This includes addressing concerns related to privacy, security, and biases in training data. Approaches like data preprocessing, algorithmic fairness measures, and diversity in the development team can help promote ethical and unbiased machine learning systems.
That's a great point, Paul. It's crucial that we work towards mitigating bias to create fair and inclusive machine learning applications.
Absolutely. Machine learning has incredible potential to improve efficiency and enable intelligent decision-making in various domains. From healthcare to finance, the applications of machine learning are vast and diverse.
That's right, Paul. Machine learning algorithms have the ability to analyze large datasets and discover patterns and trends that can be used to make informed predictions or decisions. This has revolutionized industries such as healthcare, finance, and even self-driving cars.
Absolutely. Speaking of self-driving cars, the article mentions how machine learning algorithms are used in navigation systems to provide real-time directions, analyze traffic patterns, and optimize routes based on user preferences. This integration of machine learning in self-driving cars offers a range of benefits, including improved road safety and reduced traffic congestion.
Definitely. However, there are also challenges that come with implementing self-driving cars. The article mentions ethical concerns, unpredictable scenarios, and cybersecurity vulnerabilities as some of the challenges that need to be addressed through ongoing research and development.
That's true. Ethical considerations are becoming increasingly important as machine learning is integrated into various industries. One major concern is bias in machine learning algorithms, which can perpetuate societal inequalities and discrimination. It's crucial to address this issue to ensure fairness and inclusivity.
Absolutely. Bias in machine learning algorithms can result from biased training data or the algorithms themselves. It's important to carefully consider the data used to train these algorithms and to regularly evaluate and test them for any biases that may be present.
Transparency and interpretability are also important ethical considerations when it comes to machine learning. Many machine learning models function as black boxes, making decisions without providing explanations. This lack of transparency can be problematic, especially in high-stakes domains like healthcare or finance.
That's a great point, Paul. We need to ensure that machine learning models are explainable and provide understandable justifications for their decisions. This is not only important for accountability, but also for building user trust in these technologies.
Absolutely. Another ethical consideration is the potential for malicious uses of machine learning, such as deepfakes and misinformation campaigns. These raise ethical dilemmas and highlight the need for responsible use and regulation of machine learning technologies.
Definitely. Responsible data collection and use is also crucial. Machine learning models often require large amounts of personal data to be trained effectively. This raises concerns about privacy and consent. It's essential to have proper safeguards in place to protect individuals' personal information.
I completely agree. Addressing these ethical challenges is essential to ensure the responsible and beneficial implementation of machine learning in society. We need to prioritize fairness, transparency, and privacy to build a future where machine learning works for everyone.
Absolutely, Paul. And it's not just ethics that we need to consider when it comes to machine learning. The article also highlights the importance of risk management in algorithmic trading.
That's right. Algorithmic trading, which refers to the use of computer algorithms to automatically execute trades in financial markets, has gained significant popularity due to its potential to improve trading performance and efficiency.
However, it also introduces new risks that must be effectively managed. Risk management in algorithmic trading involves identifying and mitigating potential risks associated with the use of algorithms. This includes assessing the reliability and accuracy of the algorithms, monitoring and controlling the execution process, managing operational risks, and ensuring proper compliance with regulatory requirements.
Absolutely. Effective risk management strategies should be adaptive to changing market conditions and capable of addressing emerging risks in real time. This is essential to ensure the success and stability of algorithmic trading strategies.
Definitely. The last section of the article focuses on transportation and autonomous vehicles. Autonomous vehicles rely on machine learning algorithms to interpret data from various sensors and make informed decisions without human intervention.
That's right. Machine learning enables autonomous vehicles to learn from their surroundings and adapt to different driving situations. This has the potential to reduce traffic congestion, improve fuel efficiency, and eliminate human errors that cause accidents.
However, there are challenges that still need to be addressed. Regulatory hurdles, ethical considerations, and the need for robust machine learning algorithms to handle complex driving scenarios are just a few of the challenges mentioned in the article.
That's true. Despite these challenges, autonomous vehicles hold great promise in reshaping transportation and revolutionizing our daily commute. It will be interesting to see how this technology continues to develop and how it will impact our lives.
Absolutely. Machine learning is a field of study that has the potential to transform various industries and sectors. From healthcare to finance to transportation, machine learning algorithms have the power to improve efficiency, enhance decision-making, and create a better future.
That's right, Ben. And with that, we've come to the end of today's episode. We hope you found our discussion on the main points of this article informative and thought-provoking.
Thank you for joining us, and we'll catch you next time on our podcast. Hey everyone, and welcome back to our podcast. Today we're diving into an interesting article that discusses the main points to consider when it comes to bias, fairness, privacy, interpretability, and the impact on employment in the field of machine learning. These are all crucial aspects that deserve attention and understanding as this technology continues to evolve. So let's jump right in.
Absolutely, Ben. One of the key considerations highlighted in the article is bias and fairness. Machine learning models built on biased data can perpetuate and amplify existing biases, leading to unfair outcomes and discrimination. This is why it's essential to identify and mitigate bias at different stages of the machine learning pipeline. Techniques like balanced sampling, algorithmic audits, and fairness-aware learning have emerged as ways to address these concerns. It's not just a technical challenge, but also a social and ethical responsibility that requires collaboration between computer scientists, social scientists, and policymakers.
That's right, Paul. Another critical concern in machine learning is privacy. As ML algorithms heavily rely on data, there is a risk of personal information being exposed and misused. In the age of big data, where vast amounts of information are collected and analyzed, it becomes even more relevant. Machine learning models often require access to sensitive data like personal identification, financial records, or medical history. If this data falls into the wrong hands or is mishandled, it can have serious consequences for individuals and society. That's why organizations and policymakers need to establish robust privacy frameworks and ensure appropriate measures are in place to protect personal data in machine learning applications.